Okay, let's look at some problems to help you review for your Chapter 7 test that is upcoming. So these first couple of questions go back to Section 1 where we're dealing just with those formulas for midpoint and for distance. Now if you recall what the midpoint formula was, the midpoint formula says take x1 plus x2 divide it by 2 and then do the same with the y's, and that would give you the coordinates of your midpoint. So if I look at that in this problem, that would simply be 1 plus 2 divided by 2 and negative 3 plus 7 divided by 2. Now 1 plus 2 is 3, and 3 divided by 2 is 3 halves. Negative 3 plus 7 is 4 divided by 2. And I can simplify 4 over 2. I can't simplify 3 over 2. So it's 3 over 2 and 2. So if I graph those 2 points, the point that would be right in the middle of those 2 points would be 3 halves, or 1.5, and 2. Okay, let's look at the same 2 points, but now we'll look at the distance between them. Now we also had a formula for distance. If you remember what that formula was, it was the square root of x1 minus x2 squared plus y1 minus y2 squared. So again, we're subtracting the x's, squaring them, subtracting the y's, squaring them. So if I use these 2 points we're given, I would say 1 minus 2 squared plus negative 3 minus 7 squared. So 1 minus 2 is negative 1 squared. Negative 3 minus 7 is negative 10 squared. Negative 1 squared is 1 times 1. Negative 1 times negative 1, which is 1. Plus negative 10 squared, which is positive 100. So this is the square root of 101. Now on the test, you certainly could have a radical that breaks down, but 101 does not factor, so there is no simplification that could be done. So this would be the distance between those 2 points. If you want to give the decimal approximation, that would be fine too, 10.0 something, very, very close to 10, but a little over it. Alright, then we moved on to section 2, which talked about circles. So if you remember the equation of a circle in standard form, it was always x minus h squared plus y minus k squared equals r squared. So these things inside the parentheses are the center, they're just the opposite sign. So since this is in standard form, the center is simply 4, the opposite of negative 4, and negative 1. 4, negative 1. The radius, now this 9 is the radius squared, so the radius would be the square root of 9 to get rid of the square, which is just 3. So this would be a circle with a center of 4, negative 1, and a radius of 3. Alright, let's look at our next problem. The next problem says, convert to standard form this circle x squared plus y squared minus 4x plus 6y plus 4 equals 0. So the first thing I'm going to do is I'm going to move this 4 to the other side by subtracting it. And when I do that, I'm also going to write the x terms right next to each other, so that's x squared minus 4x. I'm going to put the y squared plus 6y next to each other, and now this is going to equal negative 4. So we convert this to standard form, if you recall, by completing the square. So I take half of this number and square it. Half of negative 4 is negative 2. Negative 2 times negative 2 is positive 4. So I will add 4 to both sides. I'll do the same thing with the y. So half of 6 is 3. 3 squared is 9. So I'll add 9 to both sides. So the nice thing about this is these three should factor, these three should factor, and then this side just equals 9. So if I'm looking at x squared minus 4x plus 4, I'm looking for two numbers that multiply to negative or positive 4 and add to negative 4. That would be x minus 2 twice, so that's x minus 2 squared. I'm looking for two numbers that multiply to 9, add to 6. That would be y plus 3 squared, and then equals your 9. So there's your standard form circle. It would have a center of 2 and negative 3 and a radius of 9. Pardon me, radius of 3. So a center of 2, negative 3 and a radius of 3. Okay, in our next problems, we're going to try to determine the vertex of the parabola. We're going to try to determine whether it opens up, down, left, or right. So if I look at this one, the vertex is always said by the numbers opposite inside the equation. So the vertex would be the opposite of this one, so negative 1, and the opposite of this one, which would be 4. Now since the square is on the y, anytime the square is on the y term, we know we have a parabola opens either left or right. And since it's negative, this one is going to open to the left. Now this is also, of course, very easy to see on Desmos. If I graph this, I'd obviously see the vertex. Remember, the vertex is kind of where the parabola starts to turn. So this one will look something like this. So this would be my vertex. We could also find the focus by solving for A and finding the distance from the vertex to the focus. This one over here, same idea for the vertex. The vertex would be 10 and 3.5, just taking the opposite of each of those. And the square is on the x, so it's either going to be up or down. Well, there's no negative in this case, so this one's going to open up. And again, graphing this on Desmos would be a really easy way to solve this problem. Alright, number 6 says graph the ellipse x squared over 16 plus y squared over 4 equals 1. Identify all the vertices, co-vertices, and foci. So to do this, I'm also going to have to talk about what is the major axis, what is the center, and then I'll list all those other things as well. So the major axis in ellipse, remember, always is the axis that has the bigger number under it. So in this case, it is along the x-axis. That means it'll be longer horizontally than it is vertically. The center in this case is just the origin. It's 0, 0, because if I look inside the x squared and y squared, I don't see a number. So the center is just going to be 0, 0. So I can start to graph that. There's my center point, 0, 0. So all the foci and co-vertices and all that kind of good stuff was found by using our A, B, and C. Remember the number under the x squared is a squared, because it's the bigger, and the number under y in this case is b squared. So a squared is 16 and b squared is 2. So a is going to be the square root of 16, which is 4, and b is going to be the square root of 4, which is 2. So this is actually plenty of information to graph my ellipse, because remember, a is the distance from the center to the vertex, and b is the distance from the center to the co-vertices. So if I go 4 from the center in either direction, those are my two vertices. So if I want to list what those are, we have two vertex, one at 4, 0, one at negative 4, 0. My co-vertices are up and down 2, because remember, I went the vertices left and right because the major axis was the x-axis. So my co-vertices just going up and down 2 are going to be 0, 2, 0, negative 2. So my ellipse is going to look something like this. And definitely you could graph this on Desmos and see a real nice picture of it. What Desmos won't give you is these coordinates of these foci. and that's determined by C. And I don't have C from the equation, all I get is A and B. But if you recall, we have that little relation for ellipses that says B squared equals A squared minus C squared. So if I put those values in, B squared is 2 squared, which is 4. A squared is 4 squared, which is 16, minus C squared. Also subtract 16, so 4 minus 16 is negative 12, equals negative C squared. So I have a negative on both sides. I'm just going to cancel that out and make it positive, and then I'll take the square root. So C is going to be the square root of 12. So C is the square root of 12, which is the distance from the center to the foci. And if I wanted to, I could reduce that radical. This becomes 2 radical 3 if I'd like to. I'm not going to worry too much about that. But remember, our radical simplification is very important. So if I look at radical 12, which is, a little less than 4, a little over 3, so I'm going to have a foci somewhere over here and one over here. But our coordinates for those foci will just be radical 12, 0, negative radical 12, 0, because again, they are on the x-axis, they're going left and right. All right, let's look at number 7. 7 is also ellipse. It says, what is the center of the ellipse graphed by the equation x plus 3 squared plus y minus 2 squared? Well, the center in this case, very simple, just like the circle. The center is just going to be the opposite of those numbers in the parenthesis. So the center will be negative 3 and it will be positive 2. There's lots of other information we could get from this ellipse. For example, the major axis is the y-axis. Along the y-axis it would be up and down, longer up and down, because the bigger numbers under y minus 2. Now it would look something like this, longer, because we have that center over at negative 3, 2. We also know A would be 5, because A is always the bigger one. B would be 1, and I could use my my little equation, B squared equals A squared minus C squared, to find C if I needed to. It actually turns out to be square root of 24. But all the same stuff that we did in the previous problem, but I just want to kind of point those things out. Since this question was pretty easy, only asked for the center. Alright, the last question on here should probably be the most popular, because it says, match the following conic equations to their appropriate graph. Well, anytime there's a graphing problem, we can graph any relation in Desmos very simply. So this is really not going to be very difficult to do. But I'm going to kind of go through the theory, kind of describe the equations, see if we can do it that way as well. So if you look at these, of course, we have all these different hyperbolas. And we want to see which hyperbola matches which equation. So the first thing I'm going to do is I'm going to look for the center of each of these. That'll give me kind of an idea. So the center of this one would be 2, 1, because that's just taking the opposite of each one. The center of this one would be negative 5, and nothing in this one, so that would be 0. That's the center of that one. The center of this one would be negative 3 and negative 4. The center of this one would be 1 and 7. So that itself should be a pretty good idea of which one is which. Let's also discuss which way it opens, left, right, or up, down. Now the way the hyperbola opens, up, down, or left, right, is determined by which variable comes first. So in this case, the y comes first. If the y comes first, it's a hyperbola opens up and down, because that's saying the transverse axis is the y. All the good stuff is going like that. In this case, it's also y first, so this would also be one that goes up and down. And has a center of negative 5, 0. This one has an x first, which means it's going to have good stuff on the x-axis, or that direction, so this way, this way. And so this one has, again, x on the first, so that's going to go this way as well. So this should be plenty of information to actually match these up. So this first one, we're looking for something that has a center of 2, 1, and it opens up, down. So it's either going to be B or it's going to be C. It's not going to be B because you can see, or C, because you see the center somewhere in between these two is going to be here. So that's definitely negative 5, 0. So 2 is going to be C. So by process of elimination, we know 1 is going to be B. So it says as a center of 2, 1. 2, 1 would be right about there, and that looks like it's the center of those two curves. So now we just have to match up 3 and 4. We know it's going to be A or D because those are the only ones that are left. So 4 has a center of 1, 7. Well, if you look at 1, 7, that's way up here on D, so it's definitely not D. So 4 is going to have to be A because you can see 1, 7 is somewhere here, and that seems like a reasonable center for this one. So 4 is going to be up to A. Easier said than done to draw a line. And then, of course, 1, or 3, pardon me, which had a center of negative 3, negative 4, should be somewhere down there. Opens left, right, so that one would be D. And again, graphing these in Desmos would be a really good way to go. Alright, so hopefully this review and some of the corresponding questions helped you to prepare for your test. Let us know if you have any questions.